So of these 4 topics, one of those will show up as a workout style problem.
Not the bat problem.
It's up there, CBAT problem.
But not that one.
But not the bat, no, I don't know. I would suggest studying it.
Sounds like it's pretty attached to that problem.
I have a good variation on the bat problem that I like a lot. I have put it on the test many a time. Not really. Maybe chromatic dispersion is kind of easy. That could be like a bonus question.
I don't know, I'm just saying, but chromatic dispersion.
But chromatic dispersion, yeah, no. All right, so post-midterm for lecture 5, the bulk of that was that the curvy mirrors? Is that when we got to curvy mirrors?
Yeah, and then 6 was lenses. 5 was mirrors, 6 was lenses.
Really? Because I thought mirrors and lenses showed up in the same lecture.
No, you definitely did mirrors first.
Because we did plane mirrors. We did plane mirrors, and then we did reflection and refraction. And that was Snell's law. So that was lecture 4, when we did plane mirrors and refraction through into prisms and stuff. And I'm pretty sure lecture 5...
5 was convex.
Lecture 5 is mirrors.
We did really briefly with mirrors. We said that the angle of incidence is the angle of reflection. But that's it. That's all we said about plane mirrors.
Yeah, but it was concave and convex.
When we got to lecture 5, that's when we got to concave and convex mirrors and lenses, right?
Yep.
Yeah, lecture 5 was mirrors and lenses. This was with geometric optics. And that was part 1. Yeah, that's right, because part 2 is when we did telescopes and microscopes. Yeah. So here's a review mirror and lenses worksheet that's in the final exam folder on the course website. I have very frequently put a problem on the test that just gave you 4 pictures and you just had to answer those 4 questions. So that's also a favorite of mine. And that's so easy. If you've done the worksheet already, you can just go through, boom.
So that's in the lecture 5 folder?
This review worksheet is in the final exam folder.
In the final exam.
So that's a good thing to review. I mean, there's a lot of problems that are good. I mean, I like geometric optics because there's not a lot to be tricked by. Here's the focal length. Your object is here. Find the image. This is the height of the object. How big is the image height? So what's the magnification? Blah, blah, blah. So
Like focal length and lens maker's equation.
lens maker's equation.
Those ones you probably want to
Yeah.
wake up on.
Yeah, I don't think there's really nothing from lecture 5 that I don't like. It's a good one, so.
Lecture 6 I did.
But probably not glasses, eyeglasses.
Oh, thank you. Or microscopes.
Microscopes and telescopes, probably not. Because especially the microscope, you have to have the picture in order to know what all those variables mean. And that's a big picture to put on your sheet of notes. So, yeah, but that was lecture 6. So lecture 6, when we did geometric optics part 2. So we won't be on final. So that's your microscopes and telescopes. But then we also started interference, right? We had interference.
This is my notes.
Okay. So that was our ideal Young's double slit experiment. So that's a good one to review. I know it gets really confusing when the next week we learn about diffraction and then we get the real Young's double slit experiment. You can kind of make sure that you get those differentiated in your mind, and I will do my best to write problems to... I don't think the equation really changes. I think that the only thing we got new when we learned about the real double slit interference pattern was we got that intensity equation that was disgusting. Okay, I am not going to give you a problem that requires you to use those big, ugly intensity equations.
So then we're not spending 2 hours just writing out the equation?
Yeah, or what mode is my calculator in, and yeah. That was lecture 7. So that was diffraction. So the intensity questions won't be on the test.
Speaking of calculator mode, we can just assume radians for...
That's a safe bet. That's always a safe bet, yeah.
So gradients actually have a reference, they mean something. Degrees mean reference. Degrees mean something.
So the things I like about diffraction, and it's like always good to know what your teacher likes, right? I like the stuff where we got to diffraction gratings and spectrometers and resolving power and that kind of thing. And remember that equation for resolving power, which was N times M equals lambda, was it delta lambda over lambda or lambda over delta lambda? Is it like this? Anyone have that handy by chance?
Isn't it 1/2 lambda 1, lambda 2 minus lambda 1?
I was trying to figure out which is on top. Is lambda average on top? Lambda average, okay, yeah. So just reminding you guys that I want this to be an average of lambda 1 and lambda 2. The book equation is not an average. So, okay, and then modern physics. So lectures 8 and 9, modern physics. Some of these questions are kind of difficult to put on a test, but I would say the ones that lend themselves nicely to test problems are the photoelectric effect, like knowing that graph, understanding how to read that graph, because that's a nice thing to, you know, it's a easy way to represent a system by just plotting the graph of the photoelectric effect, and then I can ask you, like, find the threshold frequency, find the stopping potential, find, if you know the value of an electron, find a predicted value for Planck's constant, you know, all kinds of things you can find just from that graph. So, so that's a favorite for me, photoelectric effect. Not so much a fan of the Heisenberg problems. I gotta say, not so much a fan. Hydrogen atom, the hydrogen atom problem, like we did the last one we did as an example, I think those are fairly straightforward. You might not feel that way right now, but when you go home and you think about it, I think they make a lot of sense. So I like the hydrogen atom for test problems.
Pretty much right off the Heisenberg stuff.
It could show up as a concept question, like multiple choice kind of question. And you guys liked those, right? If we decrease our position uncertainty by 1/2, what does that do to our momentum uncertainty? Doubles. Those are
I'm okay with it.
yeah.
No, that doesn't make sense to me.
Well, the concept questions are nice. Yeah, they're nice. So,
Like 6 of those on there. Good, that'll be-
anything else? Is there anything that I'm missing that people want to ask about?
Doing the black body radiation problems, or?
It's probably on the other one.
I don't know. I hate to like throw things out just because, but if I'm throwing out, I already threw out the intensity calculations for diffraction, so I might as well throw out the intensity equations for black body. I don't know. The reason I'm reticent is because you've got one equation for intensity and then you've got another equation for intensity, and one is the area under the curve and one is a specific point on the curve. And I do remember they had different units, but it creates a whole lot of confusion in my brain. And when you're in that test mode, it's very good that we learned about it, and it's good you learned it and did it on your homework. I'm not sure that that's really a good test kind of question.
So
But-
total radiation intensity. That makes sense. That's the I sigma. Or
T to the fourth. That's the area under the curve one. Yeah, the other one, I agree. It's like, that's finding the intensity at a specific spot on the curve. Yeah.
Our total intensity makes sense.
I'll also say though, that equation is so easy, that's another reason why it's probably not going to be a test problem. But you could see, it could come back on a concept question. So we might ask, but then we had that really confusing concept question. There was one concept question and it said, if you lower the temperature, what was it?
That was the biggie.
I don't even know how to change the wording. I think it just confused some people. Where you lower the temperature, and does that increase or decrease the wavelength's intensity on? I know.
It's really vague the way they just said higher,
I know.
lower wavelength, higher than what, lower than what.
I think maybe we've ruled out black body radiation on the test. We didn't like the concept question, and we don't want to do the test problems. Okay, so I'm going to put that. No black body radiation. Okay, I better take a photo of this so I remember what I'm allowed to put on your test.
Yeah.
Any other questions? All right.
Like I said,
I'll turn off the video now.